Hello, everyone. I'm Brennan Lafferty, publisher of Rubber and Plastics News. Rubber and Plastics News is your organizer of ITEC, the International Tire Exhibition and Conference. Welcome to ITEC's Ask the Expert, our live stream series featuring the latest technology in the tire and rubber industry. With Ask the Expert, this is your chance to learn from professionals who are addressing the current business environment and discussing its latest developments. ITEC has a number of Ask the Expert sessions scheduled each day this week and next. The entire library of Ask the Expert sessions are available on our virtual event site, itecvirtual.crane.com. Today, Ask the Expert will explore transformative opportunities in production system and machinery design. Our expert today is Mike Hovey, Global Sales Manager, Tire at Bartell. Mike will answer questions after his presentation. Now, to submit a question, email rpnevents@crane.com, or if you're watching this live stream on Facebook, LinkedIn, or YouTube, send your questions through those platforms. With that, I'll turn things over to Mike Hovey at Bartell. Take it away, Mike.
Hi, everybody. Thanks for the introduction. So I'm Mike Hovey from Bartell. Bartell is a machinery manufacturer. We're based in upstate New York. We specialize in the design of custom production machinery for the wire and cable industry, the oil and gas industry, and the tire and rubber industry. And Bartell is considered a technical leader in all the industries we service. And being a technical leader, we're constantly having to adapt to new technologies that are popping up within the industries that we serve. So today, I wanted to take the opportunity to talk to you about one new technology, the Internet of Things, and how it's influencing our design of equipment and our customers' experience in the production environment. So let's get right into it. We can skip to the first slide. So let's first talk a little bit about the traditional state of industrial machine design, and we can skip to the next slide. So if we look at the traditional design pressures that go into the design of a new piece of machinery, there are multiple stakeholders who weigh in on the design concepts of a machine. So on the customer side, we're typically talking to an engineering group, a procurement team, maybe even maintenance and support personnel within the customer's organization. So each stakeholder, they have different design pressures that they would like to express. So, the engineering team may be interested in maximizing productivity of the machine. The maintenance personnel may be more concerned with machine safety or simplified maintenance procedures. And the procurement team, typically they're driven towards cost concerns. So everybody has different concepts and different concerns that they try to express in the design of the machine. We could skip to the next slide. So as that translates to the design cycle for the machine, traditionally the design of a machine, it starts with a customer requirement. So we're looking at the basic requirements of the machine and the customer specifications. And then having a meeting with the machinery manufacturer, in this case being Bartell, those basic requirements are used to come up with a basic design of the machine. So when we talk about the Internet of Things, we see this as a developing technology that's really influencing the implementation cycle of a machine right from the very beginning. So, when we're sitting down and completing initial design concepts for machines, we're in a situation, in recent years where customers are really driving us to consider IoT functionality throughout the entire design of the machine. We can skip to the next slide. So getting into IoT, we could skip ahead one more slide. What is the Internet of Things? It's kind of a broad term and it's used in a lot of different ways. But, for today's purposes, I'm going to define it as the capability for individual machines in an upper level network to communicate with each other. So this upper level network is within the production environment. It can be premise based, within the plant or within the factory, or it can be cloud based, or both. But the important thing is that you have a number of individual machines and workstations and data points within the factory that are all communicating with each other and with this upper level network. So, from the standpoint of a machinery supplier, we're taking data typically related to production information, machine health, product inspection information from inline inspection systems, and consolidating this data and communicating it to the upper level network. And then as this data is tracked and consolidated within the network, it can be used by the plant or the customer to drive different processes that are intended to maximize the efficiency of the machine and the efficiency of the plant. We can skip to the next slide. So, how is this network being made with the machine? The IoT connection with the machine, it's typically being done with an industrial router that we're placing within the automation panel of the machine. So with this industrial router, we're able to take, all IoT enabled devices that are designed into the machine and connect them to the router so that these devices become visible on the IoT network. So IoT enabled devices, this is going to be the machine PLC, the HMIs, potentially cameras, smart sensors, and just a plethora of any kind of device that can be networked, and tied to this router for communication to the upper level network. So once these devices are connected to the network through this router, it provides access to the machine and access to the devices, and remote users can now start accessing this information remotely from anywhere on the network. We can skip to the next slide. And as you talk about, creating this network with multiple different types of devices and multiple different machines, what we see is typically OPC servers are being used by our customers. So with an OPC server, users are able to create a unified architecture, and this supports the creation of a data access layer communication. So with this, data tags can be defined to communicate the critical data from each device that's connected to this IoT network. And then OPC hubs can be provided, creating a gateway for this data to be integrated into further information management networks like MES or ERP types systems, or even just a corporate display where from the corporate level, they can consolidate some of this information and just generate, readouts of OEE for specific types of machinery or, different segments within the factory or between various plant sites. We can skip to the next slide. So with this improved access to data from the machines, what it does is it really creates new possibilities for supporting individual machine efficiency and plant efficiency. So basically, it becomes a lot easier to begin logging data from the machine. You can begin logging and trending, production data, production output, alarms from machines, error messages, and things that affect the overall operating efficiency of the machine and the plant site. With the, and with feedback from smart sensors and critical machine components, you can start to use some of this data to better plan preventative maintenance for a machine. So, as you consolidate data and you have similar machines running in your plant or multiple plants, you can look at the OEE for each machine and start to really get a better estimation for what OEE should be for particular machines. and then use that information to really dial in on, what may be holding back operating efficiency on a particular machine. And then, use your resources more effectively for preventative maintenance to correct deficiencies. The other thing that remote access really does, the thing that we're seeing is that it really opens up the opportunity for remote vendor support. So for us as a vendor, when a customer calls us with a problem on their machine, maybe they replaced a motor, a servo motor, or a drive, and something just isn't working correctly. Having the ability for a vendor to remotely access the machine really makes it more efficient for us to troubleshoot problems, in cooperation with the customer. So, if there's an issue on a machine, we can tap into that machine. We can look at the PLC, we can have a live view on, what's going on in the software on the machine, take feedback from the trouble, and, use that information to guide the customer in troubleshooting the issue, just more quickly and effectively. And there's no need for us to send a service tech on site to troubleshoot the problem. So I don't know how many times, in the past, there's a problem that the customer is having, and we get a service tech on site and he's able to diagnose the problem in about 5 minutes. A lot of those quick, easy problems that, sometimes something's missed in, the customer's independent evaluation of a problem. We can pick up on, what's needed to correct a problem very quickly if we can just have direct access to the PLC on a machine. So, having IoT connectivity of a machine supports efforts like that. We can skip to the next slide. Looking at, some future applications for IoT functionality in machines, one of the areas that we're beginning to explore is using an IoT feedback from the machines and linking data from inline automated inspection systems to recognize problems in the production process. So with an automated inline inspection system, we can begin to trend inspection data from a machine and start to recognize things like tolerance creep in the product that's being produced. And where we really want to go with this, and what we're doing in some of the machinery that we produce, is, as you develop the software that analyzes the inspection data, in many cases, you can actually have an automatic intervention where the inspection system instructs the machine to change the setup or production parameters on the machine to bring the product tolerances in line to where they should be. So, this is pretty advanced stuff where, you don't necessarily need to produce product, have it taken from a machine, measured offline, feedback, manually, or, inspection results manually generated by a person, and then that person goes back and tells the operator that they need to change something on the machine setup. In some situations, and where we're looking to do this more and more in the equipment that we're designing, is to have these automated inspection systems directly linked with the machine, and to be able to analyze data from the inspection systems to automatically dictate the setup parameters for the machine to ensure that your product is always perfectly in tolerance. We can skip to the next slide. So looking at some of the other applications for IoT functionality in machines, and looking towards the support side, I mentioned before, having the ability to remotely connect to the PLC on the machine. Taking it a step further than that, another area where we're looking to develop is with augmented reality, and developing an augmented reality connection to the machine. So you could take IoT data from the machine and linked with a augmented reality device, which can be a cell phone or an iPad. You can create the opportunity for, say you have a maintenance engineer that's walking around the machine. There's an alarm message that's triggered on the machine. The maintenance engineer is capable of doing something like taking this iPad or the cell phone, walking around the machine, and through this AR interface, they can actually visualize the data that's being generated through the IoT systems on the machine. So they can see, readouts from various sensors on the machine. They can have an AR, an augmented reality overlay on the real world image of the machine. So they can actually see, data coming from these IoT sensors in a real world overlay, on the image that's being generated through the cell phone or the iPad. So let's say that there's an error message being generated from one of the sensors or an alarm message. That that engineer, the maintenance tech, can walk up to the machine, look through the iPad at the machine, and see information related to that error message. So they can point it, at the sensor that's generating this error message. They could see information related to the error message. And what this would allow them to do, as you have the error message, using this iPad or whatever, you can actually pull up information related to troubleshooting that error message. So, you get an error from a sensor, you can pull up the troubleshooting guidelines, giving that maintenance person tools for addressing the error message, or take it a step further than that. If it's a problem that's very difficult to correct and they need outside service, they could use the same iPad to pull in remote support from the machinery manufacturer, and then have live support, someone, a service tech on the machinery manufacturer side who could step in and give them live assistance in correcting the error message. So it's basically having a virtual service tech at your disposal, through this, through an iPad or a cell phone. And we're doing some of that stuff now, and continuing to develop the software and support capabilities to really enhance, those capabilities on the machine. So, what that does is it really makes maintenance and troubleshooting of a machine a lot easier and more efficient. And it's also going to, improve response times for support from the manufacturer, and, reduce travel costs and things like that. If you can avoid sending someone on site to support the machine, that just makes it less expensive and more efficient for everybody. So we can skip to the next slide. So in conclusion, as a machinery manufacturer, what we're saying is we're seeing a rise in the demand for IoT functionality and equipment. Our customers see a payoff in using IoT functionality to collect data from the machine and use that to drive better efficiencies from their machines and throughout the production plant. So, I think it's IoT it's becoming more commonplace within the plant, but we're just continuing to see more and more momentum driving towards, implementation of IoT functionality throughout the machine design. We can skip to the next slide, and that's it. So thanks. If anybody has questions, feel free.
All right. Really interesting stuff, Mike. Things you never could have dreamed of 30, 40 years ago are right at our fingertips now. So as a reminder to our viewers, if you have a question to submit to Mike, email rpnevents@crane.com. Or if you're watching the live stream through Facebook, LinkedIn, or YouTube, send your questions through those platforms and we'll get them over to Mike. So Mike, first question we do have is, to what degree are your customers currently using IoT technologies?
Yeah, and so it really varies customer to customer. We have when you get into plants, production plants that are fully automated, typically in these plants, if it's a greenfield project, they have a network integrator that's creating the IoT network connections between all of the machines, and they have a standard. They'll have a complete specification for connecting all the machines, and they'll have a developed MES and SCADA system and stuff like that running through the plants. And for us, when it boils down to the machine level, typically customers that have fully developed interconnectivity of machines, they're really driving that level of data collection down to the component level of the machine. So there's customers that are they want feedback from every servo motor on the machine, every drive. We're doing smart sensors, smart proxes, smart, it's basically every component that has IoT capabilities. They're driving for the use of those capabilities.
Yeah.
And then there's other customers who are just starting to make remote connections to the machines, and just starting to pull basic production data from the machines. So it's happening to varying degrees, but I'd say that in recent years we're really seeing more and more momentum driving toward complete connectivity of machines.
That's an interesting point you make, because I can imagine the larger companies, as you say, they want data from every motor, every piece on the factory floor. Do you have any advice for some of those smaller companies out there, whether it's a plant manager or even an owner? What kind of first steps would you take, or would you advise a company to take if this is still brand new to them?
Well, the evidence seems to support that the more ability you have to collect critical data from machines, and the better your ability to use that data to drive efficiency of your machines, you're going to have a payoff. So, we're also in development right now of a system for it's really driven towards collecting data that defines OEE, alarm messages, error messages. So, critical data that defines operating efficiency of our machines, and the same system can be used, and applied to basically any machine in the production plant. Mm-hmm. And these, what people are discovering is that once you can make use of that information, it has a huge payoff. So, you go into some plants and basic production information and production efficiency information is being collected manually from machines. So, there'll be a team of people that goes around the plant and collects production information and productivity information and operating efficiency information manually, even in some plants with notepads and things like that from each machine. Once you have an infrastructure that allows the automatic collection of that data, you can collect that data and you can be much more accurate with your data collection, much faster, more efficient with the data collection, and then use that to really focus in on driving efficiencies from each piece of machinery. So the higher degree to which you're able to make use of that information, the more efficient you're going to be, and the more payoff you're going to see within the plant.
Yeah. So also sounds like you're saying, if you haven't done this before, time to test those waters, because you can really drive some efficiencies in your facility.
Yeah, absolutely.
So here's another question that came through. To what degrees are you seeing automation used in machinery system design?
Yeah, it kind of goes back to the presentation. If you go back, maybe 10 years or whatever, like there was, IoT was just a concept. But we're at the point today where IoT functionality is being considered right down to the component level. And, in many cases, customers, if there's an IoT capable capable available for any particular need, components, our customers are requesting that we use IoT capable components. So, it's not happening to the same degree with every customer, but there are machines that we're building where, we're putting every piece of IoT capable componentry into the design of the machine.
Yeah. So I guess here's the converse of the question I asked a couple of minutes ago. When we were talking about customers who haven't done much in this arena yet. the converse of that would be, how soon do you see mass adoption of IoT within production environments? Are we 3 years away, 5 years away, 10 years away? What do you think?
It's funny too, because, for us playing in the oil and gas industry, the wire and cable industry, and the tire and rubber industry, it's different from industry to industry. If we just talk about the tire and rubber industry, movement towards IoT functionality in machines has just really, really accelerated in the last 5 years. So I'd say that just to throw out some guesswork, I'd say within the next couple years we're going to see. Well, yeah, it's almost, there's some degree of IoT integration in almost every single machine that we produce now, but the data points produced within the machines and the number of data points and the different types of information that's collected from machines, I think it's just going to continue to accelerate. So I'd say it's almost at 100% mass adoption now, but the degree to which, so all customers are using it to some degree now, but I think that what we're going to see is continued movement towards heavy usage of IoT data points throughout all componentry on the machine, within the next 5 years.
Yeah, especially as companies replace older, outdated equipment. Yeah.
Yeah, for sure.
So, Mike, let's talk just briefly. In the context of this world we're living in, the pandemic, COVID-19, have you seen technological innovation speed up because people are hunkered down in their offices now, or has it slowed a bit? What's the insight there at Bartell?
Well, I mean, the pandemic's only been going on for about, I don't know, what is it, like 6 months now, I guess, full-blown pandemic. So, not a big window to allow, any monumental changes in technology. But, if anything, I think the pandemic has really, emphasized the importance of being able to work remotely. And so, with the IoT stuff, there's a machine level focus. So, it's used to drive efficiency on individual machines, but that data is also used to, analyze data from the plant level or the corporate level, looking at efficiencies from, multiple plants or factories nationally or globally. So, with the pandemic and people working remotely, and everything's migrating online. I mean, look at us doing a virtual conference here. If anything, the pandemic is just, really enforcing the move towards digital and the importance of, being able to communicate data remotely.
I was really fascinated by your discussion about augmented reality. I was able to see some of that in person at a trade show when there were trade shows in person. But is augmented reality a reality at Bartell now? Is that can someone, as you said, use an iPad or use their cell phone to walk around a machine and get the data points and see what's actually going on there?
Yeah, we have working concepts, prototype technology. We haven't, fully commercialized it yet, as a complete offering, but the technology for sure is there. And then the development that's required, it's writing the software that allows you, immediate access to the information that you want to send to the customer to support, different situations on the machine. So the technology really it's right there, and it should be coming quick.
Interesting. Wow, that'll be fascinating. And then maybe one of our final questions is there a lot of training involved? Again, thinking about maybe some of these companies that are, a little newer to this. Is there a lot of training involved that Bartell supplies even when you're talking about IoT?
Typically no. Like, so if customers start, it would be, we would have the capabilities for sure to support a customer. But what we see, we're the machinery designer and manufacturer, and our making use of IoT technology is in response to demands that we see in the market for these capabilities within the machines. So, when we're starting to see these demands, in order for customers to start to generate the demand for IoT capabilities within the machine, typically they have a group within the company that's already focusing on implementing those types of technologies. So, I don't know if Bartell would necessarily be the group that you'd go to for, initial training and support. I mean, for sure, for our equipment, we'd be there to support implementation of IoT and, integrating, IoT functionality with our particular devices. We'd be there to facilitate that. But we wouldn't necessarily be the people to train your team on IoT technologies, as part of like the broader consideration.
Yeah, that's fair. That's fair. Well, Mike, I think that is all the time we have for questions today. Thank you for such a great presentation. Any final thoughts or parting words of advice for our viewers out there today?
No, I hope everybody enjoyed the presentation. I thank you for your time, and if there's anything that I can do or Bartell can do to support you, please feel free to reach out.
Awesome. Well, as Mike said, if you want to reach out to Mike with additional questions, you can use the web address, the email address on screen. I know he'd be happy to speak to you. My thanks to our expert, Mike Hovey, Global Sales Manager, Tire at Bartell. My thanks to you for joining us today for iTech's Ask the Expert. For more conference sessions from iTech, visit itechvirtual.crane.com. I'm Brennan Lafferty. Thanks for watching iTech's Ask the Expert, organized by Rubber and Plastics News.